support, one space, okay.
Okay.
But mine was the Katrina base, so it was space. Yeah. And Joe
I think it's working still. Okay, should still be working. All right, so welcome back. One thing that I'd learned, but I just didn't remember, is that these markdown cells, some versions of Markdown support HTML, some don't, but ArcGIS's implementation does support HTML. So this is just straight up HTML that I put in there. So if you've made a little bit of this is HTML that is that's requesting this picture of a kitty cat, and so I can put that in. So even if you're not familiar with Markdown, but you're more comfortable just writing in HTML, you could do that as well. That's another thing. Oh, I now made that one Markdown. That one needs to be code. All right, so that runs. Okay, so why don't we just keep going in this particular cell in order to cover most of what we have left. I introduced almost sneeze. Sorry. I introduced variables already, and assignment, but that's pretty much the topic of the next chapter in the book. Chapter 2 is variables and assignments, and the book actually talks about what's referred to as a state diagram. And as you read about state diagrams, which is basically just a diagram saying what variable is assigned what value, because that can change over time. Let's show that example. I think we already did this, but let's just say I said x equals 5, right? And then I print x, and then I say x equals 10, and I print x. What's happened? Well, it's going to print 5 and then it's going to print 10. Okay. So what happened inside the computer?
So then the 5 is overwritten by you change the variable again to 10. So whatever was previously x is not x now.
Right. So that's exactly right. Now, in my other analogy where I said that x is basically a container, I took 5. I originally put 5 into the container, the value 5 into the container, and then later I took 5 out and put 10 in the container, and each time right before I did everything, I asked it, what's in the container? That's all print does, is say, hey, what's in this container? It's a function that asks what's in the container. So if I was going to draw a state diagram of that, then it would be a pretty simple state diagram. It would be, x is, sometimes in state diagrams you just draw an arrow. X is 5, and then x was 10. So I just modified that value. A variable is just the name of the container. Okay. You can name containers whatever you want with only a very few exceptions. One of the exceptions is that you can't put spaces in the names of your variables. So if you say like, thing 1 equals 5, you're going to get an error. Okay. Right here, it's trying to say, okay, 1 is equal to 5. That can't even happen. So spaces don't work because spaces are used for other things in the language. You could say thing underscore 1 is equal to 5. That's legal. So you can do that, but you can't say thing is equal to 5. Thing space 1 is equal to 5. There are several words that you can't use. For example, you can't say false is equal to 5. Why? Why do you think you can't say false is equal to 5?
Because false is used for something else.
Right. And technically, false is actually already a variable. So I'm going to run this. I'm going to get an error. But I can actually ask, not a variable, a value. Type type false. What do you think it's going to tell me if I do this? No, the type of false. So type is actually a Boolean value. A BOOL stands for Boolean value. So I can't use false because it's already a value. It'd be like saying 1 is equal to 5. No, you can't. I can't say 1 is equal to 5 because it's not. Okay, you can't assign a value to a literal. All right, there are several others that are on the list that you can look up. Most of them have other meanings to Python. So none, true, and, as, assert, break, class, they're all in there. They all have meanings, and we'll learn probably the meaning of 90% of those values later in this course. But those can't be variable names because they already mean something else.
Dr. Wade,
Yeah.
when you're typing in GIS book, and you assign a variable, a particular thing, notice you write in a certain syntax in order for the computer to read the name. Like you sound like the name of the city or name of a railroad, but you write in such a format that normal computer program would do make an error, but you're typing the Python label, I think, because you just write names, with the pathways, but along the pathway, you assign a name to, like a particular name or whatever the particular is, and then once you run this program, assign the value to the left side of the program, which is in the context. But it's just how you assign the value name as you have to name the output value. When you name the output value, you put a name to the output value. Like in the Python, when you were assigning the names, you know what I'm talking about?
I don't know. I mean, one of the questions that sound like you're asking is, can you name a variable anything or something that'd be useful, right? Like you could name a variable, Hattiesburg or Gulfport. You could name a variable Gulfport or whatever.
In there, and then you just change names right on the end of the program. I know that in all the programs, eventually once you get to the detail of the program, you got to output a name, you just type it up. No one really realized that you were writing the syntax there. You just can't say anything.
Yeah. Well, if it's a string, if it's a literal, like if you need to have a string, then you have to put quotes around it. But it's always the name of the variable is equal to the value over here. That's the format. So what you're doing here is you're putting value into this variable. You're putting whatever's here into that box. So I'm going to comment this line out because that's just a comment. And I could say city name equals New York. See how I have to put this in quotes because It's the value going into the variable called city name. And it has a space, and space is okay there because it's in quotes, right?
Right.
And it's part of a thing. Now, I could also say, so that's going to work. My shapefile equals, c:/temp/test.shp. That isn't the path to a real shapefile, but that's a real path. I mean, that variable is going to be stored in here. If I run these, nothing bad's going to happen yet. Okay. Now, if I actually tried to open that file, I might get an error because that file doesn't exist. That's a different type of error than we've been talking about so far. That's not a syntax error. That's a logical error. That file doesn't exist, and so I'm not going to find out that error that file doesn't exist until it tries to open it. But I can still print. Whoops, didn't mean to do that. I can still print the value of my shapefile. Oh, sorry, I forgot to put parentheses. That. Okay, notice that it printed out something weird. Well, that's because Python doesn't like slashes. So I can put a little R right before this value and tell it to ignore the slashes. What's happening? It's not letting me. My shapefile, I'm in insert mode or something, equals R :test /test. All right, I'm going to rerun this cell. This is one of the advantages to interactive Python. I reran this cell. Now when I run this cell again, it'll get the right value. It'll show me that correct value. We were going to cover this, but a little bit later. So slash is a special character inside of a string.
Print doesn't run the shapefile. It just actually prints out the syntax or whatever we wrote before.
Yep. It asks what's in the box, and in the box is just the path. The path is what's in the box. The string. So if I type in type of my file, what am I going to get if I run this?
Text.
Yeah, I'm going to get string. It looks a little different here than it does in in the Python, but in the interactive window. Like if I did this, here, and then print type of my. Oh, there we go. Enter. It says class string, whereas it just says str there. But it's the same basic thing. All right, we're going to do a little bit of just interesting things that Python can do, or things that you might use. So one of those things is that you've already noticed is order of operations. Okay, so I did that OR statement earlier, but even in terms of math, there are orders of operations. So if I said A is equal to 6 times 2 plus 5, actually here I'm going to do the opposite. 6 plus 2 times 5, what's going to be the answer?
Does it do it like the math order of operations? Like, does it on here do that?
It does do it like the math operation. So it'll be 16. Oh, I'm just going to. So the reason that it's 16 is that 2 times 5 is 10. It does that first, and then it does 6 plus 2. So multiplication is before addition. Okay. Not a big deal. It's not even a big deal if you can't remember it. It's not something you're going to be tested on. This is just something that for you to keep in mind when you're writing a program. You could make an error in your logic or in your math because you forget to do about the order of operations. Now, what I do, because sometimes I can't remember, parentheses always trump everything. So you could put parentheses in, and then you're going to get the different answer, because it's going to do 6 plus 2, which is 8, times 5 is 40. So when in doubt, throw the parentheses in because they'll be useful and they'll help out. Okay. So parentheses say I want to do 6 plus 2 first, then I want to add 5. Okay. Also, one of the things that becomes pretty useful in Python and any computer programming language is being able to manipulate strings. What's a string? Text, right? We want to be able to change things inside of strings. So we're going to cover a few different string manipulation, or what we call string operators, right now. What if I had a string that said a name? Name equals George, right? I have a string that says George, and I want to actually print hello. But I also want to print George, but I want to be able to print what's in the variable. So maybe I want to say hello to everybody, and I get a name from everybody. Name 1, name 2, name 3. So how could I take the string George and the string hello and push them together? That's called string concatenation. So string concatenation in Python is just done with the plus operator. So hello plus name. So what's it going to print here if I type in hello plus name?
Hello, George.
Yep. So if I run this, it says hello, George. Now, if I wanted the comma and the space, I have to put them in there. I'd see the comma and the space there. So if I had just written, hello, and I ran this, it would literally put hello, George next to each other without any spaces in between. So if I want the comma and the space, I need to put them in there in order for it to work.
And you said this string what?
String concatenation. So this is what I could do. Make this markdown. I got to learn how to spell better if I'm going to do this. So now I've got that in there. I run that. I just a little comment. I could have created an actual comment, or I can do it as a markdown code line in my code.
Could you put a point next loop in there where you just name a list of people and make a statement, and then go to the next statement, and just go and list a part of the name?
Yes, and we will cover that next week. We'll start talking about that. All right. So a few other things. Okay. Let's say we've got. We can do this. We could say name times 5. We can do that. That's actually illegal. What do you think that's going to do? Yep. It's going to repeat George 5 times. I don't know why. I've never actually used that in anything, but that's an example of that operator doing something else valid. We could. What's that?
So whatever the variable is, it don't matter what's in the variable box, is going to chime it.
If it's a string. If it's a string. If it's a number, what will it do?
Do the operation.
Yeah. So look, watch this. This is what I'm trying to get at. So if I say age equals 5, or I say s age equals 5, are those different? Yeah. In fact, if we were to say age equals s age, what's the answer going to be?
Okay, is age.
Is age equal to s age?
Okay, is age equal, okay.
My guess is false.
It's S age 5. So, yes. Okay, S age equals 5. Okay, so you don't check. Okay, then you go back and say this age equals S5.
Do these values equal each other? Are they the same?
Mean does. So it should be true, right?
No, it's false. Why is it false? I heard some people say false.
One's the number,
The
one's
red
the
5
text.
is actually text and not a
Yes,
place
right.
of the number, and the 5 is indicated back number.
Yes, that's exactly right. So these are different things. So now watch. If I say age times 5, and then I write s, well, let's do that one. Let's run that first. So we still get the fault. Now look, age times 5 is 25. Let's do these as separate cells just so we have them. So this is going to be false. Age times 5 is 25, whereas s age, also known as sage, I guess, times 5, what's it going to equal?
5 5.
Exactly. What data type is that, though?
It's a string, right? So it's 5 string, right?
Right. So that's a string. It's a string with 5 5s, but it's still a string. Now, we can convert back and forth. There are operators, there are functions for converting back and forth. So if we wanted to say int s age times 5, we run that. Now the result is actually, see how it's not in quotes anymore? The result has actually been turned into an integer. So that's another function that you didn't know before. Okay, that function turns a string into a number. Now that function's going to have problems turning name into an integer. How do I? What is? Remember what name is? Name's George. What integer do you think is George? Well, it can't. It cannot turn George into an integer, so you get an error. So your string has to contain an actual number. It won't even, by the way, it won't, like even if I wrote number equal to 3, it's not going to like that. Let's say I tried to convert 3 into an integer. going to give me an error. Can't convert letters into numbers. Your string can only contain numbers if you're trying to convert it into a letter. I mean, into a number. So that is an important thing to remember, this lesson here, that age is equal to 5, sh is equal to quote 5 quote. Those are two different things. One's a string, one's a number. You can convert back and forth. In fact, the way to you could. What's that? Sorry.
So integer just drops the quotes essentially.
So
that's the only parameter that you can put in that it recognizes is like a string as a number. So you're just taking away the quotes.
Right. Yeah, you could think of it like that, but in reality, the quotes don't even actually exist. The quotes are for you. The quotes don't exist in the computer. The quotes are telling, so that you know when it prints it, it puts the quotes there and tells you it's a string. But the quotes don't actually exist in the computer's brain. The computer knows that it's a string. The computer knows that it's a number. And when it reports it to you, it puts the quotes around it to tell you this is a string.
Well, if that was the case, why does sage times 5 equal 5 instead of 25? Because the computer has to recognize it to some extent.
Right. But the computer stores it as a string. It doesn't store the quote things by it.
I see what you're saying.
Yeah.
So it's going to always be a string.
It'll be a string until you convert it away from a string. You can convert things out. So if I type in string and put 5 in there and run this one, oh, sorry, that's not the name of the function. The name of the function is str. So str 5 converts it into a string. So now we have the string 5.
Are you in Markdown or are you in the normal one?
No, I'm running code. The only Markdown one is this one right here. And this one. This one's Markdown. That one's Markdown. The rest of these are all Python code. I'm running Python code. So, let's. Do I have the book up here somewhere? Oh, sorry. So here's the book. So if you were doing the lessons in the book using interactive Python, which is what I would recommend, either using interactive Python or using ArcGIS Python. Okay. Either one's fine. So we're doing exercise 1, which is just here's exercise 1.1, right? In a print statement, what happens when you leave out one of the parentheses? So you could type print hello. What happens if I leave out the parentheses? Oh, I get an error. I leave out one of the parentheses but not both. I get an error, but it's a different error. If I leave out this parenthesis. So those are problems. Okay, so I could do that there. And then on to the next one. If you're trying to print a string, what happens if you leave out one of the quotation marks are bold? I'm trying to print out a string right here, so I can just change this, modify it. This time I'm going to leave out one of the parentheses. So it's going to give me an error. It says end of line while scanning string loader. In other words, it actually thinks this is still part of the string. And it's saying you never closed your string. You haven't closed it. Even if I put it here, What's the problem with this?
Is outside of, parentheses, should be inside of it.
Right. Now, I still need, if I put that other parenthesis, now I'm going to get a valid statement, right? See, look at how it's going to print. It's literally going to print hello with the parenthesis after it. See how that works? It's because this is inside the quotes, it's part of the string. It doesn't care if it's a real word. I can put whatever I want in there. I can put like numbers and all that, and that's all still part of what's inside of it. See what I'm saying? It's just a bunch of text. A string it actually stands for a character string. It's just a bunch of characters all strung together. The only exception to that is actually the slash. The slash means that I want to do something special. So /n actually means that I just want, maybe it's the other slash, sorry. Yeah. So slash, it's this slash. The other slash is fine. This slash means that you want to have a new line. There's a couple other special characters that can be fine. So I'm just going to put this new line. So go ahead and save that. All right. So go back to the book for a second. We're on, okay, if you can use a minus sign to make a negative number like 2, what happens if you put a plus sign before a number? What about 2 plus 2? That'd be interesting. I don't know. Let's see what happens. 2 plus 2 on that guy. 4. All right. So it doesn't matter. It's the same thing when you say 2 plus positive 2 is still 4. Unless it's... Okay, yeah, it's the same. That's the same thing. Okay. So that's how you would do these exercises. All right. And then we've already done this, but you could do it again if you wanted to. So we did these string operations, and now we're on to the exercises. So now you could do these exercises by yourself. Or we could do, let's do the first one together. Okay? Repeat my advice from the previous chapter. Whenever you learn a new feature, you should try it out in active mode, make errors on purpose, and see what's going on. Okay? Not my advice, the book author's advice. Okay, n is equal to 42 is legal. What about 42 equals n? You think that's going to produce a legal thing? 2 equals n. What do you think is going to happen?
Well, you were saying 42 is a variable, which is the box. Equal n, that's an unknown value.
N's an unknown value, but what about name? Is name an unknown value? Name's not unknown. We defined A up here. Oops, we're in the wrong window here. But let's just say we did that. Okay. Well, actually, let's just say x is equal to 5. 42 equals x. You think that's going to run? You think it's going to be valid? What do you think's wrong with that?
You're trying to assign literally.
Yes. So 42 is being assigned the value x. That's what equals means. So if I run this, it says I can't assign a value to a literal. So I'm trying to assign the value 42 to x. And it says, you can't do that. I mean, sorry, other way around. I'm trying to assign x to the value 42. And it says, you can't assign x to 42. Even if I did this, it's not going to work. Okay? Even if y is not known, it's going to say, you can't assign anything. You can't put a literal on this side of the equation. Even, George is equal to y isn't going to work. No matter what it is, you can't put a value on this side and a variable on this side. They always need to be the other way around. That's the proper syntax.
Can you say print x and still with print out 5?
Sorry, what?
Can you say print x? 5, right?
Oh, yeah.
Okay, okay.
Oh,
It's unassigned, okay, it's unassigned because that 42 error is wiped out the value.
right. It made it so that the whole cell has to execute correctly for anything to occur. But yeah, if I typed in x is equal to 5, you're right. This would work. That is something about interactive Python that's different than. So if I did that in here, look, if I said x is equal to 5, and then I said 42 is equal to x, and then I said print x, it will give me the value 5, and that's because interactive Python is executing every cell together. In Python, in ArcGIS, it's running every line by line. So like I said before, interactive Python is a kind of a mix between running it at the interpreter window and running a script. You have to think about each of these as their own scripts. So this is a script, this is a script, this is a script. Every cell is its own script. So if that script runs successfully, you can build on it. If the script did not run successfully, you can't use that information in any further script because that script didn't run. Also, when you run these things, later anyway, maybe I'll remind you of this later, but when you actually hit run here, if it's running, it puts a little star. It's too quick to even see it, but it puts a little star right here while it's running. That's just for you to know later when you write a really, really long program. Let's say like this.
So as you write it, Dr. Raver, do you test as you go through because you're writing a massive program, do you test each line?
I don't test each line. If I'm writing, lots of times I use interactive Python to develop, and I'll write certain parts of my code together, and then I can test them together to see if they work. So that's one of the other advantages of interactive Python. I don't test every single line, but even if you were to write a fairly long script, well, here let's think about, even though we're not moving on to the next one yet. Okay. I'm going to go back here, file, I'm going to save. I'm going to open up another new Python window here. Okay. This might give you a better flavor for So I have a little comment there. I wrote it in Markdown. And now I'm going to write a simple script that calculates the distance between 2 points. And so if you guys don't remember how to calculate the distance between 2 points, well, does anybody remember how to calculate the distance between 2 points? Let's like look it up, because we don't really need to know that, right? Distance, formula, distance between 2 points. I don't know what purple math is, but let's see. Okay. So if we remember, the Pythagorean theorem is a squared plus b squared equals c squared. We can use the Pythagorean theorem to figure out the distance between 2 points because it's the hypotenuse of a triangle. So what we can do is find out the distance between those 2 points is simply the difference in x and the difference in y. So this is the difference in x, and that's the difference in y. And then we just plug it into that formula. And so it might be helpful to think about our program as what it needs. I'm going to rename this one point. All right, so what do we need? What are the inputs if we're going to write a program to calculate the distance between 2 points? What are the inputs?
You need A, B, and C of that, describe what A, B, and C are. So you would say,
well, what are they? I'm trying to find the distance between 2 points. What do I need to know?
The points.
Yeah, the points. Yeah, I need to know the points. Now, we've only talked about numbers and strings, right? We can make more complicated things. We could make a point, but we haven't really talked about point data types. We've only talked about numbers and strings. So we're going to treat each point as each coordinate in each point as a separate number. So we could do something like this. x1 is equal to, x2 is equal to, y1 is equal to, and y2 is equal to. So those together are going to make 2 points. So the x and the y, 1 is 1 point, and the x and the y2 are 1 point. See what I'm saying? So what are some coordinates that we might want to use? Just come up with 2 points in Cartesian space.
30, 90.
30, 90, and then what's another one? What's that?
20, 40.
20, 40. You guys like to pick nice round numbers, right? We can do 25 just for fun. All right? And so I've set up 4 variables, and I've called each of these variables a number. I've given each of these variables a number. So inside the x1 box, I have 30. Inside the x2 box, I have 25, and so on. Okay? So I have these numbers in the variables. And what I want to do is calculate the difference between the distance between point 1 and point 2. Okay? So I can look at my formula here and see that the first thing I need to do is calculate the difference between the x's and then the difference between the y's. So let's do that. Okay. So how do I calculate the difference between the x's? Just call that x diff. What's the difference between the 2 x's here?
X1.
Yep.
X2.
Now, for the distance formula, it actually doesn't matter which one you put first as long as you're consistent, because there's a square later. So we could say x1 minus x2 or x2 minus x1. Wouldn't matter.
Would it be 5?
Yeah, it's going to be 5. Right. Now I have to be consistent, so yeah, I have to do y2 minus y1. Oops. Now, did I make a mistake? Yes.
Yeah.
Yep. Now, if I want, I could print x diff and y diff right now just to see that it's working. I have to put parentheses, right? I'm going to put a comment here. Say, print the differences just to see if they are working. I'm going to run this guy. So yeah, I get -5 and 50. So by the way, you can print as many values off as you want. If you just put a comma in between them and you print off a bunch of different values. I have 2 values I wanted to print off, so I printed off 2 and I put a comma in between. All right. So is that right? Is the second one right? The difference between y1 and y2, is it really 50?
Yes.
Yeah. All right. Maybe I want to put a comment here that says,
You change those numbers where they make it positive, you change 25 and put it up. You said,
yeah. Yeah, so if I opposited these, 25, 30, 40, 90. I don't even know if that's really a verb, opposited, but yeah, it would do that. Okay, I can even put step 1 calculates the difference between x and y. What's step 2?
what to find the difference between those 2 points.
Yeah, I got to square both of the differences. That's this part of the formula right here. So I got to square both of these differences. So that's the next part. So I'm going to call this x sq. How can we square? We already learned that, right? X diff times 2. That works, right? Y sqr. Now, what if I didn't learn that? Would this be a valid statement as well? Would this produce the same thing? See this right here? Is that the same thing as saying because this is saying x to the second, and this is saying x diff times x diff. Aren't those the same thing mathematically? I guess this isn't a math class, but those are the same thing mathematically. Now if I want to print those, I can do that. Now that's not going to work. The syntax is I need a comma in between there. I'm going to try to run this. So now I've got 25 and 25000. Are those correct?
Right, because the answer would be 5 for the other one. Square between each other is 25. And is that 50? 50 times 50? That's 25. That's correct.
I'm just commenting it out a little bit more. All right.
Dr. Ray, if you didn't know the diff there or that was so complicated because if you don't know what you put in those, you can never use Python. You got to know what.
Okay. I see what you're asking. Okay, somebody else. Why did I write x diff there, or what does x diff mean?
Whatever you want to estimate. Because like you're just assigning it for your reference.
Yes. Yeah, Benjamin's correct. I don't have to name that x diff. I could name that whatever I want. That's a variable. It's a box. And what I'm doing is telling it to store this value, x2 minus x1. I'm asking it to store that value in there. So I don't know, Elvis, are you asking if you didn't know to call? Go ahead.
Well, that's the name of the variable. So, I mean, you answer 2 questions in one. I mean, so you're really saying that the variable can be anything you assign it, but you got to understand that you just have to do it in that order. I just thought that diff would be a difference, which makes sense, you know, to me. You are naming it, it has a unique name, and it's what we're trying to do to find the difference.
Yeah.
So I don't understand how you do it, but if it's not something set.
So that he can quickly glance at it and know
You want to name it something useful that you'll understand. But the name doesn't matter. So now I'm going to rerun this program. I'm going to get the exact same result because that's just the label I gave it. Now, you also might be asking, well, how did you know that to get, I'm going to go rename this. How did I know to that I needed to calculate the, how did I know that I needed to calculate the difference in order to get the distance? Well, that's maybe I didn't know that, but I'm just implementing this formula here. So some of the challenge of this course will be getting it into Python, but I actually think that that's the easier part. Once you kind of learn the Python syntax, that's actually the easier part. And that's the part we're going to go over for the first 3 weeks of the course. The harder part of this course is saying, okay, this is the GIS problem I want to solve, and we're going to tackle this GIS problem using scripting. But both of those are problems in this course, and that question that you asked, which is a good question, kind of gets at both of those. That, yeah, I need to know how to logically get the answer to my problem. And that's the first step. And then once I know how to logically get the answer to my problem, in other words, I understand the steps to get the answer, I also need to write the code to do that. And I also need to understand why the code is written as it is. So right here, all we're doing is assigning a value out to there, and then we're doing it. All right. So there's one more. Yeah, go ahead.
Can I say one more thing too? So you're saying that you have to understand what that math problem is saying in order to translate it into a Python statement. You looked at that problem and said, I'm trying to find a difference. If you didn't know that, it would be hard for you to write the calculation for that problem in Python. You wouldn't know how to understand.
Right. Yeah, if I don't understand how to solve the problem, I'm not going to be able to solve it using Python code. Right? I need to understand how to solve the problem. And you've probably heard the term before, algorithm, right? You've heard that term. Everybody hear the term algorithm?
Yes.
Okay, even if you haven't heard that term, I'm telling you it right now. And it sounds like it's a complicated term. You might think it's a math term, but really it's not. And the term algorithm is a series of instructions for solving a task. That's what an algorithm is. Like, in the broad sense, a recipe is an algorithm. I could say, I created these chocolate chip cookies using a special algorithm. Okay? It's like it's a series of instructions for completing a task. Now, you wouldn't say that. People would think you're a nerd if you created cookies and you told them that you followed a specific algorithm. But that's what an algorithm is, and that's how it's different than a formula. A formula is still actually a formal language representation of a task. However, it doesn't tell you all of the individual tasks that you need to do in order to complete that process. Whereas an algorithm does. An algorithm is those set of instructions. Now, oftentimes when you're writing code, the process is to first come up with an algorithm. In other words, a set of instructions for completing the task. And then in Python, you come up with, you first write pseudocode. In other words, it's code, but it's not completely, it's more like English code, but it's close to the Python code. In other words, you might write one comment out for every specific Python task that you're going to do. And that's kind of what I'm doing here. So when I said create point 1 and 2, step 1, calculate the difference between x and y. Print the difference. Step 2, square both of the differences. And finally, well, actually, depending on how you do it, you could actually have a step 3 or a step 4. But what I need to do is, to finish this, is to add them together and take the square root. Okay? That's what I need to do. And so my pseudocode is that comment, and sometimes it's helpful to write all the pseudocode comments that you'll need and then fill out the code underneath. That's what I'm trying to show here. So step one, I've shown each of the steps here, and the final step is this right now. Now I can think about, okay, what actual Python code do I need to write in order to get that to work? So what is the Python code that I need to write to get that to work? Anybody have any suggestions? First of all, which variables am I going to operate with? By the way, let's go back to here real quick. This is what I'm trying to do right here, this step. Okay. Sorry, what'd you say, Ashley?
You're going to add your square roots that are what you did when you square them. So your x is q and y is.
I'm going to do what to them?
You're going to add square root bit, but I don't know what's the syntax for the square root.
Okay. So I need to add them together, and that's great. So you're asking the question, I know how to do it, but I don't know the syntax. Okay? I don't know the syntax. So how could I find the syntax? Well, I could just tell you the answer. Okay? Or we could look up and find square root, not toot, square root in Python. All right. So it looks like, let's see, this guy could help us. Okay. So it looks like it says, open your Python interpreter, type math, then import sqrt and press enter. It loads the square root module. That's not something we've learned about yet, but we could do that. So what it's doing here is saying, okay, well we need to, there's a space here that shouldn't be here. I need to type in import math. All right, and then I could say sqrt, sorry, I have to write in math dot sqrt. We're going to learn about this next week, but this is fine to learn about it early. So this is a function. Math is a function, and it's going to take a number and return the square root. So now if I run this, there's the answer right there, 50.249781.5. Blah, blah, blah. Okay, is there a way I could have gotten the same answer without doing that for anybody that might be a math, not math whiz, but is there a way to do an exponent but get a square root? What do you think? Maybe we don't have anybody here. What's that?
Oh, I can't quite remember, but I remember doing that in some of my classes.
So,
could you use that term?
So this will give you the same answer, so that'll run. So anyway, it's an equivalent statement. So I'm going to write that right here. This is let's see. Works. I don't know how to spell equivalent. All right. So that's an equivalent statement to this. All right. Just to give you a preview. So we still have time. I mean, normally we would get out. We get out, a little after 3. So just to give you a preview here, that import statement, import math, what it's doing is by default, there are a bunch of what they call modules installed with Python. And they have functions that are in those modules, but they're not in the Python code itself. They're not in the Python executable itself. And so they're importing, they're bringing in those additional functions. And one of those functions is the square root function, which takes a number and returns the square root of that number.
So, Dr. Ray,
Yeah.
Depends on what version of Python that you're using. Some of the modules might already be in it, but if it's like a lower version, they might not have been created. So that's the reason why you probably add those extra commands because might not be in that version that you're using. Our version may have, or may not have.
Yeah, I mean, some of it is it's just because the Python program, they don't want it to get too large, and so they have additional modules, and there are a bunch of standard modules. Math is one of them, and we'll talk about some more of them later. But for example, there's a module. There are modules that third parties, other people make that are installed as part of Python, and not installed as part of Python, that other people can install and you can use with Python. And so using the module is called ArcPy to work with ArcGIS. So if I want to type in import ArcPy, now I'm all set to use ArcGIS alongside of it. But we'll talk about that. We'll talk about that later. Okay.
So if you get into the power of 0.5, you don't need to import all that math stuff.
You don't need to import math. It does the same thing. It's an equivalent statement, exactly. There are other things inside of math, like there is math.py that actually returns pi for you. So it's just an example. I don't know all the functions that are inside of math. Like probably cosine. Let's see if I don't know what that's going to return. But yeah, so cosine, like on your calculator. So the cosine of 4 is this number. So that's another function that I don't think you could do without importing math. But I'll leave that in there. All right. One thing I wanted to do is show you that now that this is written, it's a function. It's a program. I could modify the input values. So I could say something like 4, 7, 5, 9. And then try to run this. And now I'm going to get 3, 4. And now I'm going to run this guy, and I'm going to get 9, 16. And run this guy again, and I get 5. So now the answer is 5. So that the distance between these 2 points is now 5. So I've got a script for calculating the distance between 2 points, and I just put in different numbers. Okay. And you can see that this would be a nice tool for developing your thing. But if you actually wanted to write a script to calculate the distance between 2 points, you probably just want it to run. Okay. So we'll talk about that a little bit more next week, or when we talk about functions. But that's that. Now, what's going to happen here? Normally, I'd be working on my computer. But what's going to happen is I'm going to take all the examples, all the code that I wrote today, as well as the videos that I made, and I'll upload them to the GitHub. So this is an old video. So now it'll say previous years. This will be put into the previous years, and there'll be a video of today's class, and then I'll also have all of those Python files that I wrote and the interactive Python notebook files. They'll be there. So if you wanted to run them, you could download them and put them on your computer inside of your user's directory, and you could execute them if you wanted to. You could execute this IronPython, or I keep saying IronPython, interactive Python thing. All right? So today's homework, there's nothing to turn in, but I want you to go through the chapters 1 and 2 and do all the exercises, and then start reading chapters 3, 4, 3, 5, and 6. And if you want to, start doing the exercises from those chapters as you work through them. 3, 5, and 6, right? Yeah, we're not doing 4. All right. So, yeah, like I said, normally this class, the lecture portion of this class would have gotten over an hour ago, and then we would be in the lab portion. So, I'm going to be right now. I'm going to transfer all of this code onto my computer and then upload it onto the GitHub website, and so I'll be here. So if you have questions like, hey, I can't get Python to work on my computer or whatnot, maybe we can work through those. But other than that, there's no other class meeting. So you're free to go if you need to. Yeah, go ahead.
In the GitHub site, I would go to the SPA directory where you are in. That's where I see all the updates at. The GitHub site, which takes me to the site, I will go in there, and that's where I already got it in the SPA Possum site, Possum SPA.
Yeah, you can get. You don't even have to have a GitHub account, as I mentioned before. You just go to this URL. Actually, not even that URL. Just go to this URL right here.
Okay.
MapPossum/SPA. It stands for Spatial Programming and Automation, which is the title of the course.
So there are a bunch of more. Which one went on the bottom page?
So it'll all be in M1. All the stuff that I talked about today will be in M1. So right now, M1 is from the last time I taught the course, but okay. I'll archive it and put up the stuff from today.
Okay. Okay.
I mean, we followed this outline, but the examples are from before and the videos from before.
Correct. Okay.
So, all right. So now I'm going to stop the.